All right, next up is heat transfer and energy transformation. So first off, let's talk about our vocab. So temperature. When we're measuring temperature, we're measuring the average kinetic energy of molecules in a substance. So what that means, remember, kinetic energy, that's the energy of motion. So we're talking about how fast molecules are moving. So temperature tells us on average, one molecule in this substance is moving this fast. So when something has a high temperature, that means it has fast-moving molecules. When something has a low temperature, that means it has slow-moving molecules. So temperature directly describes how fast molecules in a substance are moving. Heat transfer always goes from hot to cold. So remember, heat always goes from hot to cold. Transfers from hotter objects to cooler objects. So in these scenarios, so first off, we have I put ice cubes into a glass of warm lemonade. So remember, heat flows from hot to cold. So I think, what's my hot object? What's my cold object? So here, my hotter object is the lemonade. My colder object is ice cubes. So heat is going to flow from the lemonade to the ice cubes. Next up, I burn my tongue on a hot slice of pizza. So my hot object is that pizza. My cooler object is the tongue. The heat flows from the pizza to the tongue. Next up, I warm my cold hand next to a hot fire. So my hot object is the fire. My cold object is the hand. So the heat is going to flow from the fire to my hands. So heat always flows from the hotter object to the cooler object. And we have 3 different types of heat transfer. And remember, they all flow from hot to cold, just in different ways. So we have conduction, convection, and radiation. So conduction is heat transfer through direct contact. So remember that D in conduction, that's for direct contact. So that's with molecules directly touching each other, kind of like how sound works. Conduction is when heat moves through molecules bumping into each other. So there are 2 examples of conduction in this picture. So right here, that hand getting burnt on that hot handle, that's an example of conduction. And also, if you were to set down this pot on this hot burner to have direct contact there would be conduction between that burner and the bottom of the pot. So 2 objects in direct contact, that's conduction. Next up is convection. So convection is when hotter, less dense molecules rise, and cooler, more dense molecules sink. So let's talk about that. So remember, when we say something's hot or has a higher temperature, it means the molecules are moving faster. As molecules move faster, they're going to bounce off of each other harder, and they're going to start to spread out. So hotter things are going to be less dense, which means their molecules are spread further apart, and this is going to make them rise up. Cooler things with cooler temperatures, they have slower moving molecules. So those molecules aren't bouncing off of each other as hard. So they're going to be closer together, which means it's more dense. So that's going to sink. So in this example here, we have our pot of water. The water right at the bottom is getting heated up through conduction, through that direct contact, and it's going to become less dense. As it becomes less dense, it's going to start to rise up. And the colder, more dense water on the top of the pot is going to start to sink down to replace it. So this creates almost a circular current, and that's called a convection current. All right, lastly, we have radiation. So radiation is heat transfer through electromagnetic waves, specifically infrared waves. So this travels just like light. It can travel through space. That's why we can feel heat from the sun. That's radiation. So radiation is when you can feel heat without actually touching anything. So an example here, if you were to put your hand kind of near this burner and feel the heat coming from it, you're feeling electromagnetic waves or radiation. All right, next up is energy transformation. So our law of conservation of energy states that energy cannot be created, it cannot be destroyed, it can only be transformed from one type to another. So we can't create or destroy energy, but we can transform it. So our 2 main types of energy. First off, we have kinetic energy, which are energy of motion. That's going to increase with mass and velocity. So the bigger something is, the faster it's going, the more kinetic energy it has. And then we have potential energy. So potential energy is going to be your energy of position, so the energy you get from gravity. So that's going to increase with